everyone! Great news! Our design for the new town square is finalized. And the next step is to put it on a coordinate plane so that everything can be mapped out in more detail. The design team has to create two grids, a smaller version for the construction crew and a bigger version for a sign outside the City Hall building so that everyone can see what the new town square will look like. I have this smaller blueprint, and it's my job to scale it up for the sign. Can we use what we already know about scale factor now that the figures are on the coordinate plane? Let's see. So, today we need to scale some figures on the coordinate plane. A figure is scaled when it grows or shrinks using a consistent scale factor. Where have you seen something like this before? Yeah, in our last lesson when we worked with scale factor like this. But also when we learned about dilations like this. So, we've learned to recognize dilations and work with scale factor, but haven't gotten to actually create any images on our own. In this lesson, we get to do the dilating or scaling ourselves. When you dilate or scale a figure, you can use any point on the coordinate plane as the center or the point that the figure grows away from or shrinks toward. In this course, we'll stick to using the origin or 0, 0 as that center point, and we'll scale figures up or down from there. We'll stick to the term scaling from now on, but you can also think of this as dilating from the origin. When we scale a figure on the coordinate plane, not only does each side length expand or shrink by the scale factor, but the distance from the origin to each point on the figure also expands or shrinks by that same scale factor. In other words, the size and the location of the figure both change.
Let's dive deeper with some examples. The sign for City Hall needs to be twice as big as the smaller printed blueprint, which means we're working with a scale factor of 2. Let's start with one of the benches. Here's the small version on the coordinate plane. Looking at point A, how far away is that point from the origin? Yeah, it's 1 unit to the right, the x direction, and 3 units up, the y direction. So, when we apply our scale factor of 2, we'll multiply each distance by 2. How far away will A prime be in the x direction after applying the scale factor? Well, 1 times 2 is 2, so it will be 2 units to the right of the origin. What about the y direction? 3 times 2 is 6, so it will be 6 units up from the origin. Now that we know where A prime will go, we'll plot it on the same coordinate plane by going 2 units to the right of the origin and 6 units up, like this. Let's try with point B. How far from the origin is point B in both the x and y directions? Absolutely, it's 5 units to the right and 3 units up. After applying the scale factor of 2, what will the new distances be? Yep, 10 units to the right and 6 units up, because we multiplied each distance by 2. Let's go ahead and plot point B prime on the graph. Pause here while you find the distances for points C prime and D prime and plot them on the graph. Let's go over it. Point C in the pre-image is 5 units to the right of the origin and 1 unit up. After applying the scale factor, point C prime will be 10 units to the right of the origin and 2 units up. Point D is 1 unit to the right, and 1 unit up, so after applying the scale factor, d prime will be 2 units to the right and 2 units up. Here's the completed image. What is one way we can double check that the pre-image was scaled up by a scale factor of 2? We can check the side lengths. The long sides were 4 units long in the pre-image, and they're now 8 units long in the image. The short sides went from 2 units to 4 units. It all checks out. We've changed both the size and the location of the pre-image by applying the scale factor of 2.
What do you notice about the x and y values of the coordinates themselves? Pause and record your thoughts. I noticed that each value in the coordinates for the pre-image was multiplied by 2 to make the coordinates of the image. So I guess when we scale a figure on the coordinate plane, we don't actually have to measure the distance from 0, 0 to each point. Instead, we can multiply each x and y coordinate by the scale factor. We can even summarize this by writing a rule using coordinate notation like this that shows how each coordinate changed after we applied the scale factor.
Try out this strategy by finding the scaled up coordinates of the grassy lawn for the town square. Our scale factor is still 2. Here are the coordinates for points r prime, s prime, and t prime after applying the scale factor. Each value was just multiplied by 2. We can't fit the image on the graph that we have, but that's okay. We still know exactly where the points in the image will be, thanks to our math skills, and we'd be able to plot them on a bigger coordinate plane. Here's a new example. This time, we don't have the coordinates of the pre-image, so we need to label them ourselves. Pause while you do that. Here are the coordinates for each point in the pre-image. Point H is at -6, -4. Point I is at -2, 8. Point J is at 3, 8. And point K is at 7, -4. Now that we have the pre-image coordinates, pause while you find the coordinates of the image after applying a scale factor of 0.5. All we needed to do here was multiply each value in each ordered pair by 0.5, or 1/2. That would give us these coordinates: h prime at -3, -2, I prime at -1, 4, j prime at 1.5, 4, and k prime at 3.5, -2. Sometimes when I'm calculating coordinates and I see a decimal value, I wonder whether my answer is wrong. But decimal values are totally fine. A value like 1.5 is exactly halfway between 1 and 2, so the point 1.5, 4 won't go exactly on the corner of the grid lines, but rather right in the middle of the x values of 1 and 2. Here's what the graph of the image looks like.
Hey, thanks for your help today. Now that I know that scaling figures on the coordinate plane is all about multiplying the coordinates by the scale factor, I'm feeling good about finishing this scaled up display of the town square blueprint. You go ahead and finish up your guided notes and then complete today's online practice. And remember, math is everywhere. Keep exploring.
Hey, hey.